Alright, bro, I thought I'd make a quick little video to show you the simulated LED setup that I'm going to hook up to the Gerber laser prototype. So I ended up using the 2N3904 little transistor that you can see back here. And then I got a resistor going to the base to limit the current coming from 5 volts, which I got hooked up to my signal generator. And I've got it set up for a square wave. And right now it's just set to 1 kilohertz or 1 cycle per second. So that's going into the base. So that means the LED will flash 1 time per second. And then as I can crank up the frequency on the square wave generator, I can watch the LEDs flash faster and faster. So that's what's going into the base of the transistor. And then on the collector emitter, is where I got my LED set up here, which is running off of 12 volts. And so I had to use a resistor to limit the current running through the collector emitter side of the transistor. And that ended up being a 1K resistor. And then the second resistor is a 10K resistor that takes the base to ground when the 5 volt voltage from the signal generator is off. You want to drive that base to ground so it's not floating. So it's basically a pull down resistor is what they call it. So that's the setup for the LED. Go ahead and turn on my 12 volt power, which I got on my power supply to drive the LEDs. Got that set to 12 volts. You can see the LED is off right now. So now I'm going to turn the output on of the square wave generator. Shift out. So now that's on. And there it is, flashing at 1 hertz. 1001, 1002, 1003, 1004. So now up here, I can go to my adjust, and as you see, as I change that, I can increase the frequency. So that's 5 cycles per second. So I'll come back down here, and you can see what will happen as I do that. So I'm going to just start cranking it up. That's 7 cycles per second, 11 cycles per second, 15. Eventually it gets to where the video camera can't even pick it up. My eyes can pick it up, but the camera cannot, which is interesting. I can easily see those. Let's see at which point the camera can't see it no more. Right there. So I'm at about, 28 cycles per second. The video camera can't pick it up very well, but I can totally see it flashing by eye. Slow it back down. Back down to 1 cycle per second. So cool. So now all I should have to do is, instead of a square wave generator coming into my base, I'll hook up my Arduino. So that'll be the one of the digital output pins on the Arduino that's going to be controlling the laser on the laser cutter. And when it comes on and off at 5 volts, I should get the laser simulator here going on and off. I'm in the planning stages of building, or sort of designing and building my next machine, which is going to be a laser cutter / engraver. And I decided before I bought all the hardware that I needed to build the machine that I have in mind, that I'd test out the electronics part of the system that I'm going to need, as well as the software, and make sure that I can carry the workflow all the way from the software end of things with generating a G-code file all the way to the electronics and controller that are going to operate the stepper motors on the machine. So I've put together this sort of breadboard setup with spaghetti wiring that consists of the Arduino Uno that's going to be doing all of the control. And then I put together a small breadboard with 2 stepper motor drivers that are going to be operating the 2 stepper motors for the X and Y axes. And then for the laser part of it, I put together what I'm calling my laser simulator for now, which is driving a LED strip over here to represent the laser via PWM signal. And so I did a small breadboard for it with a small NPN transistor and some diodes to drive the LED strip via the PWM coming from the Arduino. So over here on the stepper motor prototype board, I have 2 power rails, or let me start out with the 2 drivers. These are the A4988 stepper motor drivers that I'm planning on using with 2 NEMA 17 stepper motors. These aren't the motors that I'll be using, but I had these around and I went ahead and used them just for this test. And over here on the right side of the breadboard is a 5 volt DC rail that's being powered by the 5 volt output from the Arduino to provide all of the logic level power to the driver boards. And then on the left side over here I have a 12 volt rail that's being powered by this 12 volt power supply back here that's providing the motor power for the drivers to power the stepper motors. And I'm also tapping off of that 12 volt rail over to the laser simulator to power the LEDs, which I'm powering off of 12 volts. And then I also have a tap coming from the 5 volt side over. Well, actually, the 5 volts for the to switch the transistors coming from the PWM pin on the Arduino Uno. For the software, I'm going to be using Laser Gerbil, which is an open source software for doing basic laser engraving, cutting operations. It's free off of the internet, and I've downloaded it and installed it and been playing around with it, and seems to do everything that I think I'm really going to need it to do. And that's on my PC, and that'll be communicating with the Arduino Uno via the USB cable. So I'll go ahead and what I did is went on the internet and just found this already generated G-code file that I downloaded for free and opened it up in Laser Gerbil. And I'll go ahead and operate the prototype machine here and show how it works. Okay, so I'll go ahead and run this guy. And let's see what it's doing here. So you can see the little tick mark going from the origin 0, 0 to the first start position here. And here's my servo motors doing their thing. Or stepper motors, I'm sorry. And you can see the simulated laser coming on and off as required. Cool. And here's my little Arduino Uno transmitting and receiving away. Laser Gerbil has a really good velocity and acceleration planning algorithm now that's been built into it. So just like Marlin, it does a really good job of controlling smooth stepper motor motion. And the other thing with the Gerbil laser is you can also type in specific G codes right into this line and execute G codes at will right from the computer. You can see my G codes streaming along here. So it buffers some set of them and then puts a check mark next to them after they're executed. It's got a homing routine, zero positioning. You can set offsets. Pretty slick little app. Looks like it runs really efficient. Doesn't take up much space at all. So I'll probably go with this, until I decide I need something more complex. This also does laser power modulation, which will be great for doing like grayscale engravings. So there it is. Time to build the machine. See you later.